Welcome. I'm Dr. Bill Sal, your host for the next several minutes on this webinar called Smart Technologies to Improve Road Safety. Well, over the last 30 years, I have seen the evolution of many ITS-related and smart technologies that have enhanced motorist and pedestrian safety. We'll talk over the next 8 to 10 minutes about some of those that have been probably the most significant. The advent of automated driver assist systems, as well as connected and autonomous vehicles, perhaps will for the coming years have the greatest impact on roadway safety. Certainly we could spend many hours talking about such things as edge processing, sensor fusion, data fusion, artificial intelligence, augmented reality. Unfortunately, we have very specific time limitations here. So let's go ahead and press on and we will do what we can within 8 to 10 minutes. I've been around the industry for about 30 years. I've played a role in the development of common communications protocols as well as standards established by the Standards Development Organization, NEMA, or the National Electrical Manufacturers Association, as well as played a significant role in the Saudi ATFAM project and the Mohammed bin Zayed City project in Abu Dhabi. We'll talk today about road safety challenges. We'll talk about ITS sector trends, defining really what makes a road smart. Well, I believe that a smarter road needs to be a safer road. We'll discuss worldwide best practices and very briefly, the role of the International Road Federation in making roads smarter. Unfortunately, the statistics speak for themselves. Tragically, more than 1.3 million people die per year from road-related accidents. More than 40,000 Americans die per year. Traffic accidents are the #1 cause of death for those that are ages 15 to 29. 3 out of 4 road deaths are among men, and approximately 90% of the world road traffic deaths occur in low and middle income countries. 49% of all road traffic deaths involve pedestrians, bicycles, and motorcycles. Roadway safety challenges that face the traffic engineer every day are lack of good, accurate, reliable intersection detection, a good communications infrastructure, whether it be wired or wireless, that's able to carry large amounts of data and video. Unfortunately, traffic control electronics are typically only designed to last 10 or 15 years. And what we have seen in recent years is a lack of public and private funding to allow for the replacement of those traffic control electronics. So the life cycle span has in a lot of cases been exceeded. We are expecting there to be a resurgence and pent-up demand for traffic control electronics that have exceeded their lifespan. The lack of a common communications protocol, open communications protocol that's not proprietary, and lack of a common equipment standard and specification, which allows for interoperability and interchangeability of equipment between suppliers is a challenge. As I said, the lack of public and private funding has definitely impacted the replacement cycle of existing intersections as well as the construction of new signalized intersections. The rapid development of connected and autonomous vehicle technology has also placed a burden upon the traffic engineer in that they are wondering when and how best to replace their existing equipment and what CAV enabled features should that equipment have. Should they select DSRC? Should they select 5G or some other type of communications protocol yet to be identified? With the COVID-19 pandemic, we have seen funding for ITS projects and the deployment of connected and autonomous vehicles diverted to COVID-19 testing and patient treatment. Whenever you are planning an ITS system, you really need to involve all of the ITS stakeholders. I would heartily encourage you to get all of them in the same room, identify your common needs and objectives, be willing to collaborate and cooperate, and be willing to share video and data. And you will find that you will be able to share the same equipment and share those data sets. There are more than 30 trillion sensors operational on the planet today. That's about 170 for every man, woman, and child. Sensors generate information in real time or data that's archived. When we talk about real-time data, that is generally referred to in the industry as data once per second. That is real time. It's a fact also that the amount of traffic data now collected worldwide doubles every 2 years. So how do we manage that? How do we get that back to some central location? Do we process that at the edge where it is collected? Do we transfer that to some central traffic management center for analysis? How do we go about dealing with that? What we find is that all of the data can be used to plan and design smart cities and smart infrastructure. That data already exists. We really don't need a whole lot more sensors. As connected and autonomous vehicle technology continues to be deployed, we will of course have more accurate and reliable data about individual vehicles. Shelley Rowe, the former director of the US DOT ITS Joint Program Office, said traffic data collection alone will not enhance real-time traffic management. It is the interpretation and management of that big data that's the challenge. We can have a mountain of data, but unless we can convert it into useful information, it is of no value. So really, what does big traffic data mean to traffic engineers? We need to begin thinking about every internet protocol or IP-enabled device as a sensor. Every sensor is a source of data that can be collected in real time and archived for later offline analysis. Mobility as a service, data as a service are the direct result of IP-enabled sensors connected to the Internet of Things, which, when the data sets are fused, it provides meaningful and actionable data. Searching for the right data, however, is absolutely critical. We cannot occupy communications bandwidth with data that we will not use, analyze, or if in fact we analyze the data, we realize it really doesn't tell us anything, so therefore it is not actionable data. Many of you have vehicles today that have automated driver assist systems already on them. This is comprised of radars, cameras, lidars, ultrasonic sensors, and this has been a huge tool in reducing roadway accidents. So the brain of the car is used to help automate the driving process with sensor fusion and machine learning. As future models are rolled out, artificial intelligence will be applied that will enhance the accuracy of that. Unfortunately, a lot of ADAS systems do not work under certain conditions. Whenever there are poor quality of a lane delineation, lane lines, or there is snow, ADAS systems really don't work that well. When we have vehicle to infrastructure, vehicle to vehicle data, that will assist us greatly in being able to utilize that technology. This is perhaps one of the best charts that illustrates connected vehicle technology. We have vehicle to vehicle technology used for collision avoidance, vehicle to pedestrian technology that's able to alert pedestrians to vehicles and vehicles to pedestrians and bicyclists. You have vehicle to network technology that's able to provide real-time traffic status, routing, and cloud services. And vehicle to infrastructure. This is where the vehicle is talking to an RSU, or roadside unit, placed near the traffic cabinet, which is connected to the traffic controller, which is able to optimize traffic signal timing properly, provide transit signal priority, emergency vehicle preemption priority, and I'm ready to tell you today that connected vehicle technology is ready for commercial deployment today. Now, while we're lacking the communications infrastructure, the 5G network, this technology can work on 4G or 5G NR. So it's available today, and I would encourage you, if you're interested in establishing a test bed in your city, please talk to your solution provider for that. Now, CV2X, or Connected Vehicle to Everything, offers 2 times the range enhanced reliability in terms of detection. Vehicles can actually, hopefully they will not be going 500 kilometers per hour, but the technology is supposed to work at that range. It should be more accurate and reliable than other detection technologies. And it's really self-managed for reduced cost. It should be really synergistic with and downwardly compatible with cellular technologies. It is able to use SAE and ETSI as well as NEMA standards. And so when we look at big traffic data for smart city planning or ITS planning, data really itself has no meaning. It's just a bunch of numbers. It needs to be converted into information that really is useful and easily digestible by the users. That's where data analytics and modeling comes into the picture. They can use that data and convert it into meaningful information that can be used to make real-time decisions for the betterment of the infrastructure and make traffic flow more freely, reduce congestion, reduce delays, and reduce air pollution. Predictive traffic management solutions are very important. These are coming along extremely well. We have seen them deployed in a number of locations. These allow traffic management agencies to monitor, optimize, and control traffic in a better way. You really create what is called a digital twin. So the agency can test various traffic patterns and strategies without changing anything in the field. So being able to predict traffic congestion will allow a traffic engineer to often avoid conditions that could contribute to a traffic accident before it even occurs. The International Road Federation has provided roadway safety education, best practices, and technology transfer for more than 7 decades in more than 70 countries. The result of these efforts, without question, is save lives. The IRF is the world's largest and most recognized provider of online and in-person training for roadway and transportation professionals across many disciplines. The IRF hosts many regional conferences each year, and its virtual R2T conference will be held 17 through 20 November of 2020, and registration is now open at irf.global. The 18th IRF World Meeting and Exhibition will be held in Dubai, UAE from 7 to 11 November 2021, and each of you are cordially invited to attend, with the call for technical papers being opened very soon. March 23rd through 26th of 2021, we hope to see each of you in Amsterdam at the Intertraffic Conference, which of course was delayed from 2020 due to the pandemic. And the IRF will have technical sessions, and we look forward to seeing you there. It's been a pleasure being with you. I can be reached at the information noted on the screen at any time. I know that if you have questions, you can send them via email to Intertraffic, or I can be contacted at www.argonaut.global. Now, there have been some questions prepared in advance, which I'd like to go through very quickly, if I may. The first is, what smart technologies have the most impact on road safety? Without question, I would say that coming connected and autonomous vehicle technologies will, and automated driver assistant systems will. Certainly, the seatbelt, the airbag, anti-lock brakes have had that in the years past. Number two, what are the top risk factors for roadway safety? I would say that it is probably the lack of public and private funding for the upgrading of existing intersections. Certainly, we want to deploy CAV technology as quickly as possible. We need to develop new funding mechanisms, new business models that will allow for the upgrading of existing intersections and the construction of new intersections that have the CAV technology that will take the human error out of driving. That probably is the greatest risk factor itself. Next question, how do these differ from continent to continent? I would say that in highly congested large cities worldwide with central business districts, connected and autonomous vehicles will have the greatest impact. In suburban areas, improved lane delineation and roadway barriers for interurban roadways are very important. In suburban and rural areas, vehicle-to-vehicle connectivity for collision avoidance is very important. I would say that in my travels to 185 countries over the last 30 years promoting ITS technologies, that the widespread deployment of photo citation systems for red light running as well as overspeed enforcement have been significant. We did that in the Saudi ATVAM project quite successfully. I believe, however, that human enforcement of traffic laws and the uniform enforcement of fines, vehicle confiscation, as well as jail time for those that refuse to pay, are very, very important in changing driver behavior. And I think driver training, enhanced driver training is important worldwide. There's a gross lack of proper driver training, probably not so much for new drivers, but for middle-aged drivers and older drivers. There is that need. Next question, data has been considered the new gold. In what way can data sharing contribute to road safety? As I mentioned, the collecting of real-time data and application of real-time data analytics is absolutely critical. That allows for equipment and traffic engineers to make better real-time decisions in terms of traffic signal timing optimization, route guidance, alternative route guidance, emergency vehicle preemption. That is extremely important. Next question, when it comes to influencing drivers to drive more safely, great question. There are several automobile insurance carriers in the US and Canada, as well as Europe, that have a plug-in device to the onboard or OBD2 CAN bus port that has a small cellular modem that provides real-time data to the insurance carrier on driver behavior. This is it carries vehicle overspeed data, sudden application of braking. This is very important. So there's a financial penalty associated with poor behavior and a financial incentive provided for good behavior. So again, I would say that finances are the greatest influencer. Final question, has the pandemic had any influence upon roadway safety? The answer is yes, without question. The pandemic and related country, state, and city lockdowns have greatly diminished roadway in-transit usage. Since businesses have been closed, people just have been working remotely. and telecommuting, thereby reducing the roadway and traffic-related injuries and fatalities. And while no one has a clear crystal ball about being to define a new normal or next normal, there will be additional pandemics to come, and it will change dramatically the way in which we travel by air and on land. What we have seen throughout North America is ridership and transit systems has not returned to pre-pandemic levels. Personal vehicle usage and those going to work in offices has not yet returned to pre-pandemic levels. Without question, though, the funding for ITS upgrades, as well as the deployment of CAV-enabled technologies and devices has been, as I said, diverted to COVID-19 testing and treatment. And so that has, without question, had a direct impact. So with that, thank you for your time and kind consideration. I'm available anytime to chat if you have any questions, and I'd like to throw this back to our host at this time. Thank you kindly for your attention.